Yeah, Smriti.
And who will admit people in the waiting room?
Sir, Asha is doing, and even I am doing. And there's Sonet also. So the three of us are doing that.
So welcome to the second session, the first technical session in this FDP. I'm Dr. M.Bhasi
Sir, just a
of
moment.
the Inter-University Center for IPR Studies, QSAT,
Sir,
Yeah,
Professor
sir, just a
of
moment.
Management Studies.
We can hear you.
I'll be not being able to unmute themselves and so I'll be talking on promoting research and innovation in Indian universities. Let me try the frame right. Teaching and research in higher education institutions. If we look from the time of pre-independence, last part, not the early times of British rule, but just pre-independence, the scientific output from Indian higher education system has increased. More so in quantity, very much so in quantity, but not as much as quality. There are problems. It's difficult always when you grow a sector to retain quality. In pre-independence time, pioneering work in science was done in colleges and universities. And we had Nobel laureates and great scientists who worked and who were produced from Indian colleges and universities. Maybe they won their Nobel prizes outside, but they were produced, they started their education work here. In post-independence era, applied research emphasis from universities to research institutes. CSIR labs, DRDO labs. Many separate labs were set up in post-independence era to work in the area of applied research. And universities have largely remained outside this, except for some collaborative research conducted by these labs or funded by some agencies. Within the universities, if you look at what is happening, individuals and small research groups function better than large collaborations. Mostly these groups are centered around in the science and in humanities also. It is centered around one or two professors, their research scholars, and associates. That is how research is going on in higher education institutions in India. Just a minute, I'll have to, some people are waiting in the, I'll put auto accept. So, small and large scale research in higher education institutions. We have to understand that these two are aimed at different things. Obviously, large scale research produces more impactful outcomes. If you look at the Nobel Prizes, most of the prizes go to multiple people, many a times working in different institutions, but collaborating. And if you look at when their work has started and when it got Nobel Prize recommendable winning results, it has taken 10, 15 years. So very impactful research are large collaborations and are done for a long time. In India, in our higher education institutions, research is always focused, means each component of research is around a PhD. And a PhD is not long drawn, 3 to 5 years, done by one scholar. The others in the lab also get to put their names in papers and publications which are happening. But then it is done by one research scholar supervised by a guide. So these are not very continuous, long efforts. Though across different sub-problems, they might have dealt with sub-problems of a very larger problem. When research, especially doctoral research, is formulated like that, then we have more impactful work happening. I told you earlier, scientific research by small group-based research, large collaborative research. India needs to get engaged in both. This requires radical changes in pedagogic practices, skill-based teaching, problem-solving, inquiry-based learning approaches. The bureaucracy in individual institutions need to be reduced. For easy collaboration, more flexible operations. Bureaucracy tends to decrease flexibility, increase the response time, the time required to say yes to a proposal if it is 3 months by going through the various bodies of the university, then nothing will happen. Relationship with the outside world, in particular with industry, is very important. This is more important because most of our students are not going to become teachers themselves. They are going to work in industry, commerce, or the labs. So we have to teach and train for a person to be able to enable them to work in that environment, not to become just teachers. So the teachers have to understand the environment in which the students pass out from their courses are going to work and what they are going to do. If this is not done, then there will be a misfit. And that is very visible when surveys show the decreasing employability of our students. There is synergy between teaching and research in higher education institutions. And this synergy has to be emphasized. When doing research, students gain and develop essential skill for gathering, synthesizing, and creating knowledge. Gone are the days when you can teach a student everything that student needs to know during that student's career. Whatever you teach now will get outdated very soon. Is probably a lot of it is already outdated, and whatever is in current will also get outdated very soon. So making the student capable of lifelong learning is more important. For that, exposing them to research helps. Research teachers and research staff get fresher insight into research conventions and habits, and also learn how to teach these skills if research orientation is given in the teaching also. bringing together specialized research from many institutions, from many domains. I would like to use a moment for emphasizing on this. What has to happen is one has to see where most impactful work currently happens in various domains. It doesn't happen inside the center of the domain, which is already well researched, well explored. It happens at the edges of two domains, boundaries of two domains. Now, the boundaries between domains are also disappearing. So this, at the boundary of domain, there needs to be collaboration from people working in different traditional disciplines. The key challenges for the higher education institutions now, key challenges for the higher education institutions will be to balance between teaching and research at universities and colleges, and when doing research, talking about your research output and explaining your research output in a class is just the beginning. And it may be helpful for motivating the learners to get interested in research. But then they have to be given taste of actual research. Be it small, the impact of that research, big, large problem, complicated problem, that is not important. What is more important is that they are able to carry out, understand and carry out the process of research. Training in carrying out the process of research is very important. That is what can be given to UG students, definitely more to PG students. A shift from publishing oriented research to, I'm sorry that there is a spelling mistake, patenting oriented research. They say, publish and perish, patent and flourish. If you look at science innovation, pyramid of science innovation, of course, there is theory building, there is experiments at the bottom, which are very large, and large base consists of theory and say the regular fundamental research, which feeds the applied research, which leads to innovations. Applied research leads to innovations. So there is need for doing basic research, no doubt about it. And basic research might not lead to publications. But then as a country, we have to look at, are we doing basic research for ourselves, or are we doing basic research to feed other applied research people in developing countries who will then patent the applied research outcomes and charge us royalty for their innovation? Please, I repeat, we have to ponder on, we have to think of, are we doing fundamental research just to feed scientists who are doing applied research, technologists who are doing applied research, and are we doing only that and not doing enough applied research ourselves to create intellectual property? I am of the view that that is what is happening. We are doing applied research. We are not doing enough applied research. We are doing a lot of basic research, and that feeds innovators in developing countries. And those innovations, just a minute. Renuka and then you will kill the money in class. And then, തെറ്റി വന്നതായത് തെറ്റി വന്നത് ഇനി വിളിക്കില്ല എനിക്ക് ക്ലാസ്സിൽ ഞാൻ ഓൺലൈൻ. So we need to think of that, and our ratio between the basic research and applied research needs to be changed, steered more in favor of applied research. More so because we have many problems in our society that are typical to ourselves, typical to us. They are not to be found elsewhere. So scientists elsewhere will not try to find solutions to those problems. So we have to use science to find solutions to those problems. That is why we have to do more of applied research. The second reason that we need to do applied research is because people who are eyeing at creation of wealth through intellectual property will only look at intellectual property which can bring them a lot of money. Impact from intellectual property can both be economic as well as social. Most intellectual property creators outside the country will not be interested in high social impact intellectual property creation, which does not create economic parallel and enough economic advantage. So who will do that? Who will create intellectual property which will have a huge social impact, but because it has social impact at a level of poor people who don't have paying power, so it might not create enough economic impact. As public funded institutions and as a country and as people who are educated and well off, we have an obligation to look at those problems also. We have innovated already a lot when online classes have started. In teaching learning process also, a lot of innovation needs to happen. Collaboration between institutions, higher education institutions and higher education institutions and industry needs to happen. We always talk of that, but then there is a problem. The main hurdle is who will. Collaboration means working together. Who will do what? Who will make the first move? Will I go to the industry and study that problem, or they will come to the institution with that problem? What should happen? For years, we have been waiting for industry to come to our room with their problem. It doesn't happen. It doesn't happen for two reasons. One reason is they are very busy, much more busy than we academicians are. I have been in the industry, I have worked in the industry as well as in academics. And looking at my life in both, I easily can say that life of an academician has more time, more flexibility compared to the person in the industry. Secondly, if the problem is about the industry, then the academician has to understand the industry. If the industry person comes to the academics, he understands more of academics, which is not that helpful in solving his problem. What is more required is the scientist who is taking up the problem. The teacher who is taking up this problem should understand the industry and the field. So To understand the problem itself, you should go to the field. So the first move has to be made by the academicians. Only when you have made first move, taken small problems, solved the small problems to the satisfaction of the industry, industry gains confidence. Industry gains confidence in giving more difficult, more complex work to you. I have been doing a lot of consultancy, and I have seen that starting with small assignments, you easily can move to bigger assignments. And from academics, there is hardly any competition because it's easier, more comfortable to apply for a government-funded project and complete it. Because all you need to do is do certain things and in the end submit a report, which the funding agency also does not read. But in consulting, it's a different issue. If the firm giving the consulting assignment will not gain from the assignment more than what they have invested, much more than what they have invested, the assignment won't be coming. It has to be done in a time-bound manner also. And you have to train the firm in implementing the solution. It is not just write a book, give a report. You have to help in implementation. So it finally sees light of the day. The work you do sees the light of the day. So there is need for this collaboration and especially outreach, dissemination of achievements, and we are focusing on protection of intellectual property rights. That aspect will be dealt in subsequent. So I'm not talking too much about the IPRs involved. Just a minute, my screen sharing has stopped. I will share it again. Hope it is visible. I will now take the example of ICER, this new class of institutions which were built with the focus of training all the students with a research bent of mind. The Indian Institute of Science Education and Research, founded on the concept of research universities. ICERs are designed to integrate undergraduate science teaching with high quality research. The emphasis is on multidisciplinary learning and research, and they have adopted an open curriculum. The students choose their own basket full of courses. All students gain sufficient breadth in both natural sciences, humanities, social sciences, and at the same time, they choose an area where they will gain in-depth knowledge. So a wide base, wide, multi-domain base, multidiscipline base, thereafter in-depth understanding in a particular area of their choice. And they pursue inquiry-based and research-based undergraduate programs in science education. So this approach has helped a lot. It has helped a lot because the students from ICER are seen to do well in research. See, they have large international collaborations where multiple ICERs, IITs, other institutions, and foreign other institutions, labs collaborate on project and do part of the work in their own place. These large collaborative programs feed the research and development activity at the ISER. It helps in improving the university's program of teaching and learning and creates outreach which helps the society. Let us now get into the shortfalls in the current process of research. I will just go through and try to discuss some of these areas, starting with selection of the area of research. Next, selection of the research problem, selection of the methodology, outcomes of the research, use of outcomes of research, creation of intellectual property, exploitation or use of intellectual property created. Let us look at the current process. Research area selection. How does research area selection happen? The factors which influence or dominate in the selection are given in the order of priority. They are given in the order of priority. They are institution's thrust area. If the institution has a thrust area, then the institution's thrust area is given importance. For example, if an institution is focusing on solar studies, then a person who wants to do earth sciences need not go there because this institution's thrust area is there. Within the institution's thrust area, it is prompted by the supervisor, especially in experimental sciences, where labs, equipment are needed. Then the next priority is depending on the supervisor and the lab and equipment which is available for doing research. So depending on that, the area is selected. Then we come to dimensions of factors playing a role in research area selection. Extension of the work the scholar might have done for the MPhil or for the PG course. Sorry. That is also going to play a role. Then if there is a large sponsored project, this research and area of research might be decided by becoming a sub of that large project so that all these PhDs dovetail into the large project outcome. Then there is gut feeling of the researcher or a friend or other light influences. You have heard a seminar and you want to do that work there. So such influences are also there in area selection. Then, not very often, but a good reason is for an appropriate career chosen. So if the researcher wants a certain career path, and if this research area helps that researcher get into that career path, it might be chosen. But that is often seen as, I have seen it very less of, because most of the research do PhD to meet the qualification requirement, eligibility requirement, qualification requirement to get a teaching or research job. then area more or less matters, but then the objective is very short-sighted. Then there is selection of the research problem. Selection of the research problem. Research area selection was, I said, first. After area, in that area, what is the work I'll be doing? What is the work I'll be doing in the area? So that, again, institutions' thrust area, institutions' priority, play a role in this also. In this also, institutions play a role. The research problem, most of the research scholars who have come to me have come and asked, sir, what is the problem issue? It's not good. The researcher should say, this is the problem I am motivated to work on. But instead of that, ask the supervisor. So prompted by the supervisor, a research problem will come. Mainly because most of the time, the researcher is unprepared at the stage when the researcher seeks admission. Extension work again done during PhD and during MPG or MPhil. Again, sub of a large project, then published literature review. I want to dwell on this. So for example, a person wants to research on water purification methods, potable water purification. Purification of water, which is naturally available, to make it potable. So if that is the area of work and is looking for more effective, efficient, cost-effective technologies using resources which are more easily available. So if that is the objective, then you look at literature to find out what are the methods of water purification. You look at what are the impurities present. Obviously, you start with what are the impurities present and what are the methods for removing these impurities to make the water potable. Then you will try to design a method to achieve it, which is different from what is available in literature. So you will look at gaps. For example, there aren't online non-power consuming methods which can remove certain types of impurities. For example, E. coli. E. coli want to remove a biological impurity in the water you want to remove. How can it be removed? So you might be wanting to research on that. So people have already worked on that. You will look at literature and find the gaps. And you will identify the problems where there is a serious gap. That will give you the problem. So you try to fill the gap using your research. Then what you do is, if you have come out with multiple problems, you would want to see which problem is better, which is a better research problem. Most of the time, I have not seen this exercise happen. What really happens is you try to find one problem and do it. But what should really be done is you should have multiple problems. You should evaluate them, do a preliminary evaluation, and select one of the best. So if such a research problem evaluation has to be done, and sometimes I have seen it is done or done implicitly, not explicitly, implicitly, people are doing it. One in the order of priority that I have seen, it is researchability within the given constraints. That is the most priority. Should I take this problem or not? Can I do it? will I be able to do it with the facilities, time available, and other resources, and with my knowledge. I have seen researchers. I have worked in the area of computer simulation long time back. And then when I want to persuade my research scholars to do that, most of them say it is difficult for me to learn programming, so I will not be able to do it. A very important tool they are not using because not confident of, not that the use of tool and that research will not be impactful, it will be impactful, but they are worried about their own limitations. So ease of execution, easy to execute, not too complex. Within 3 years, 4 years, I'll be able to do it. It's easy. That's a criteria of choosing problem. Difficult problems you won't take because timely completion of PhD is the priority. Then extent of risk involved. Extent of risk involved in the project. That is, you do the work, but then no interesting results come, especially in an experimental work, also in social sciences. The obvious only is answered. Nothing interesting comes out. That is, there is some risk involved. So most researchers try to avoid that risky projects. They try to avoid risky projects, but risky projects are more impactful. Risky projects are more impactful, but useful also. But then risky projects are avoided in academic circles. I would like to share an anecdote at this moment. The anecdote concerns an interview that a newspaper reporter had with Albert Einstein. So he was asked by the reporter, "You are a great researcher. So why don't you tell us in simple words what is research?" And what do you do in research? So he said, research is just exploration. Exploration into the unknown. Exploration into the unknown. So don't ask me anything more about it, because it is exploration into the unknown. And what can I say today about the unknown? Only after it becomes known, I can say something. And what do? I can't say. I can't say, because what I do tomorrow depends on what I did today and what I observe. What I did today and what I observe today will decide what I do tomorrow. So research, what I will do on this project till the end of the project, I cannot say today. In real research, there is a lot of uncertainty, there is a lot of risk. But in our academic research, we have reduced the risk and uncertainty. We have reduced it to a very great extent. And therefore, because our outcome, decided priority outcome is a PhD and not the real research outcome. So we have now the current problem, how current is the, then another criteria, risk involved I was talking about, we are risk averse in our research. And risk averse in research is bad for research, bad for the quality of research. That is what I was trying to explain using the example of Albert Einstein. How current is your problem in literature? See, one of the biggest problems the world faces even today, after we are having space tour. Rockets are flying in with space tourists, taking off, going to the space, coming back. Science has progressed that much, but still the fundamental problem of drinking water, of food, of clothing, of shelter remains in the world for majority of people. For a good, sizable majority of people, these fundamental issues, basic things of life, basic necessities of life still remain a stark reality. So just taking one end of the spectrum to space tourism is not good enough. The other end, the lower end, has also to be lifted. And many solutions to that are not in rocket science. They are in very regular investigations and methods. Publishatability of the outcomes. How many journals of good impact factor working, publishing in this area is also an important criteria for choosing a research problem. Then apparent complexity. It should not be too simple. Apparent complexity should be there. And of course, last is the usefulness, which usefulness, when I use this word, I had the good fortune of having a chance to do both my MTech and PhD at IIT Kharagpur. At IIT, in the main building, front, it is written, in the service of the nation, in the service of the nation. So there is a joke there. People go, we go into the near the main building through the main gate, and we circle around a central circle. Straight ahead of us, there is this written with neon light, in the service of the nation. Most students ask, which nation? You understanding? Which nation? Because most of the students there emigrate to developing nations, mainly USA and Canada. Now some to Australia also. So in the service of which nation? Similarly, useful for whom? Usefulness, but useful for whom? Most of our research is most useful for the scholar himself or herself, and much less useful for others. Second usefulness is for the guide and the institution ranking. But for the users of the outcome of the research, how useful? That still remains a question. So now I'm trying to discuss how or propose how a research problem should be selected. Obviously, institutions is important still, because only then will allow you to work there. Published literature review is also but then you should do a patent review also. A patent review also. At the end of this session, I'll just to demonstrate how easy it is, patent review, how easy it is. It is not easy to understand a patent. To read a patent and understand it is not easy. But reaching a patent, how will I reach or know that these patents are there? That question, answer to that question is easier. That answer to that question is much easier. I'll show you in the end through a small demonstration using Google Patents. So one should conduct a patent review. I will tell you why this is important. If you are going to innovate, why is it important? Target setting or objective setting is a very important thing in any activity. So if your objective itself was set in a different direction, how will your outcome be in the required direction? So you are doing a literature review, you are finding gap in literature, and then you are setting your objectives of the research, carrying out the research, and achieving objectives. And then after achieving objectives, you're thinking, oh, I want to file a patent. Most of the time, it won't be possible because your objective setting itself was at fault. Literature review should definitely be an input to determine the problem. But a patent review will help you understand the patents in and around the area that you are interested in. It will help you understand the patents in and around the area. And if they are Indian patents, most Indian patents, they have associated data regarding how much was the royalty received for that patents. So you will be able to get an idea of the commercial value of the patents also. Idea, I said, not complete knowledge. You will get a small idea of what is the commercial value of the patents around the area which you want to work in. So you will know what is the gap. How will I stake my claim for the patent? How will I stake my claim? What are the things which will be required to be written in the patent? What are the things I will have to find solution to? Will be discussed. What is my inventive step? I will have to answer all this. So you will know where you have to reach, what you have to be able to do to get a patent. I told you earlier that we are doing research, basic and even applied, and we are publishing. When you publish, after you have published, you lose right to patent. If you have done it earlier, publishing has happened earlier. Then after filing, no issues, but before, if you have published, then you lose your right to patent the same thing. And another inventor who does a significant jump over your published result will be able to patent this area work. So try to do a patent review, understand the patents around, which will help you understand what is practiced and used. What are the technologies or solutions, innovations practiced and used in the area around which you are going to work. With both these, discuss with your supervisor. Do a combined literature plus patent review gap analysis and identify the problem, set your objectives. So your research outcomes would be targeting patent, and you will be able to produce patents. And if you are able to produce patents, and they are useful, industry will come to you to get it licensed or to acquire, either to acquire it, have it transferred to them, or to license it for use. You research in higher education system will reorient itself to more useful work. See, in the evaluation of the research problem, usefulness should come to the top. When you are evaluating multiple research problems that you could attack or use, usefulness of the outcomes should come first. The usefulness, I said. Now I will add a third dimension. One was the economic usefulness measured in terms of money. Usefulness measured in other non-monetary terms of impact, social impact, and other things. Usefulness in terms of knowledge creation, which helped more knowledge creation, which fueled, for example, in the area of biotechnology, innovations, inventions for slicing genes, inventions which were aimed at technology to slice genes, were a very enabling technology. Because those technologies came, a lot of biotechnological innovations happened, because it provided a tool which resulted in a lot of other innovations. So it was not just an outcome, it was a tool which resulted in more innovations. So it could be, is it a outcome, simple one, a usable outcome, or is it a tool or a methodology related innovation? Methodology or tool related innovations have more impact than an outcome or research, just an outcome or research. So look at the angle of those angles, look at problem solving or need satisfaction, customer base which is impacted, a larger customer base is impacted, more impactful are you. Presence of an opportunity. There was opportunity and that opportunity was met. And opportunity for technology transfer. Are there opportunities for technology transfer? So, for example, now there is a huge problem in waste management, waste recycling. So technologies which can contribute very nicely, effectively, efficiently to this domain of recycling and waste management will be having a lot of opportunity for technology transfer. Researchability within the given constraints, important, because you take a problem which is great and you can't do anything about it. You can't do because of the constraints, but don't impose too much of a constraint for yourself from your side. In terms of, I'm not willing to learn that, I'm not willing to study that, because research will require you to get familiar with a lot of tools, lot of knowledge areas which you are not very familiar with. I mentioned earlier the importance of multidisciplinary research and research at the boundaries of two domains. At this moment, I will also add one important thing. Solution methodologies or solution processes which were used in one domain can be transplanted. Those methods, those ideas, those approaches can be transplanted and used in another domain. I am working with a scholar of mine in the area of road transportation. We are working in the area of road transportation. And we are using a lot of methods of optimization, logic for optimization, which are used in computer network optimization. See, totally different area. Road network is dealt with by civil engineers who specialize in transportation engineering. And computer networks by both computer science and electronics and communication people. They specialize in optimizing computer networks. But methods and practices that are used in one could be used in the other. So how will a civil engineer doing transportation engineering know about what are the methods in computer science or network communication, electronics engineering that he can use? That is why I said there is need to understand different domains. The transportation engineer should once in a while go and attend a conference of network optimization also. He will get ideas. Or should work in collaboration with a communication or computer science expert. Both are possible. Either you work in collaboration or you go and understand the other domain. Both are. If you want to have continued use, then better to learn. If it is going to be a one-time use, then you can just take the help of another person. Then look at the patent value proposition. Just a minute, I'll have a glass of water. Yes, thank you. I'm back. So the possibility of the patent, value of the patent that can arise from this should be a consideration for choosing a result problem. Then the extent of risk involved, obviously. But then if it is manageable risk, compare the risk with outcomes. If the outcomes are could be great, then take some risk. Calculated risk, as we call it. That is advisable. How current is the problem in patent literature? Important, currency in patent literature. When you're doing the patent search, look at the age of the patents, because patents will be allowed for a certain number of years to be live, but then India 20 years, look at the age. If it is all old patents and there is a gap, you could check why others are not working in this area. Is it because there are no buyers for new technology, or the problem itself has changed? Look at it. And patent, please understand, it is filed country-wise. So there is no global single source except for aggregators. There are patent, like Google, there are aggregators, service providers who have aggregated, and you can do a patent search on their aggregation. Google Patents is one aggregation. So otherwise, each country has its own patent regime and resource also, database also. For details, you could look that, but start from an aggregator. Simplicity in terms of technology transfer. Attack problems where the outcomes won't be too complex for transfer, because lab-based solution and industry-based solution are two different things. You can do in a controlled environment in the lab many things. The same thing you cannot repeat at an industrial scale very easily. There are many problems of technology transfer, which is technical also, which need to be solved before technology transfer can be done. So problems where, especially in the beginning, take problems which technology can be transferred easily. types of innovation based on two factors. The market on one dimension. Can you see this x-axis? The y-axis is the market, existing market or new market. And technology, existing technology, new technology. Innovations are given different names based on the combination of this. If the market is existing, and the technology is also existing, the innovation you can do is called incremental innovation, a small step innovation. Small step innovation. Innovation in small steps. So that has been happening in the sphere of automobiles driven by fuel, fossil fuels, petrol, diesel, all these automobiles, they have been there for more than centuries. And what has been happening? The market was existing, product technology was existing, but technology has been modified slowly, small increments in the technology, so that the car today and an antique car of the previous century, the 19th century, not the 20th, not the 21st, the 19th century car and today's car, there is a big difference, but then car. Existing product, existing market. But because the product became cheaper and because the per capita income increased, amount of fuel produced increased, we have more number of users. That is, the size of the market has increased. And in that, if the market is going to be new, then there is an architectural innovation. In the architecture of the system, there is an innovation. So a solar car would be an architectural innovation. It won't be an incremental innovation on a diesel car, on a petrol car. Because electronic ignition control in a modern car is an incremental innovation to automobiles. Tiltable headlights is an incremental innovation. Airbag for safety is an incremental innovation. Hydraulic brakes are an incremental innovation. But a solar power car or an electric car would be an architectural innovation, because the whole architecture, whole inside of the car will change. No longer engine is required, and how the steering will be done, and all will be a lot of changes. How the speed is controlled, everything would be changed. So it's an architectural innovation. A disruptive innovation. It is also called disruptive because some people classify it as a disruptive innovation because the fuel is also changed. Because the technology is new and the market is existing. So technology is, say, electrical technology. The main hindrance is the drives are all there. Electrical drives are all there. They are all there. And we have electrical trains, trams, and a lot of electrical vehicles already running. But then ability to store power required for a long time, that is what is missing in that. So a disruptive innovation in this will be the storage technology. Storage technology, electricity storage technology, or any other technology which will, from a small amount of fuel, say a nuclear technology, nuclear fusion technology, which will be able to be run in a small scale, not in a large scale, in a small scale to power a vehicle. Controllable, because the biggest problem with nuclear technology is controlling it. Once you start it, it gets out of control very easily. So how do you control it? You wanted to start your car from here, go there, park and switch off. How do you switch off these kind of things? So there are disruptive innovations where the market will be existing, but a new technology will change the solution completely. A disruptive technology which has come now because of pandemic is what we are using now. This meeting, teaching online. This disruptive technology has an impact on need for transportation. So a lot of need for transportation will be decreased because of this disruptive technology, not in the area of transportation, but in the area of communication. Housing problems, office space. In the area of office space market, this creates a disruptive because with work from home, all these IT companies will not need so many large buildings to seat all its employees. At any given time, they might calculate 5% of our employees need to be here at any given time. 95 will be at their home. So flexible workplace. So whichever 5 comes, they are given flexible workplaces. They work for some time and then they go off. So it creates a disruption in the market for housing and office space. Because housing, even if the connectivity is available in rural places, you go home, stay in your rural home and work and not be in your flat in the urban locality. A radical innovation is something totally new. New technology, new market. I had mentioned space travel, space tourism. So there was no space tourism. It's a new market. And the technology to take people to space and bring them back safely after a short time available creates a radical innovation. Our traveler, there is a traveler from Kerala who writes a lot of, who makes a lot of travel videos, Santosh George Kulangarya. He has also booked with, I think, $250,000 a seat for the space travel. On the lighter side, as mentioned. See, this is not very visible. Some of the technologies that are in the offering and are able, will be impacting a lot are given here. Mobile internet, it is the backbone on which the society is functioning. E-commerce, banking, insurance, even consulting a doctor or a physician, this technology is helping. Automation of knowledge work. Initially, we had done automation robotics in industries and companies where robotics was used to automate small cycle, fatigue giving mechanical work. Small cycle, fatigue providing mechanical work which needed precision. Now, bots will be, not robots, just the bots programs will be written to do programming. So, and IoT, Internet of Things, the cloud technology, which will use resources which are on the cloud so that all the resources are better utilized and in a transparent to the, without the user worrying, the user gets the services. Advanced robotics, humanoids and things like that, autonomous or near autonomous vehicles, driverless vehicles. So ultimately, you just have to not call an Uber driver, you have to call a vehicle and vehicle will come. So the requirement of roads the requirements of width of road will decrease because with lesser number of what is called Uberization, the same vehicles will be able to serve more people. Next gen genomics. I talked about cutting of slicing of genes. Energy storage, which will result in cars which run on electricity. 3D printing, advanced materials, nanomaterials and things like that. Advanced oil and gas exhaust. Percentage of oil in the area where it is drilled decreases up below a certain percentage. With current technologies, we are not able to exploit it. So we just close the well. We just seal the well and leave it. With advanced technology, more will be retrievable. Then obviously renewable energy. See, innovation, I'm reaching the last part of my talk. Innovation is not only happening and will not happen only in higher level education institutions. Innovations are happening in school also. Innovations, a huge amount of innovations are happening in the industry. The typical Indian innovation is called jugaad. It does not have intellectual property rights, have not been taken by the people doing jugaad. But if they want, many of the jugaad can qualify for IPR. But since it is being done by people who are not aware of IPR, they are not able to put it into, convert it into an IPR and claim it, stake their claim on it. So in industry, and especially the small scale industry, more of jugaad happens in small scale of industry, small workshops, rather than in big industrial units. So innovations are happening, but many of those innovations don't convert themselves into intellectual property per se. I am showing here some of the innovations. This is by two school students from Arunachal Pradesh. They suggested that instead of having a water filter in every home, why don't you have it a water filter at the tap, common taps from which the village is supplied water. So have it here so that all the people get clean water at a lesser price, because buying this unit for each house is expensive. But buying a unit for the village, it will be very less expensive and it will be useful, and you have to maintain only one equipment. See, this is an innovation by another school student. You have a sling. Usually, when you have a hand fracture, you use a sling, which is around your neck. If you have had it for 10-15 days, you will realize the burden on the neck and the discomfort. So he said, have a sling for some time and also have a hand rest, which is attached to your waist, on which you can rest your hand. So not both. So when you are tired of this hand rest, put the sling. When you are tired of the sling, put the hand rest. See, why didn't we think of this earlier? Printed paper. We have a Xerox machine into which you feed a paper and you get a copy of the document that you have. We thought of the reverse. I feed a document and I get a plain paper. I feed a document into the machine and it gives me a plain paper. It will help you recycle so much of printed paper that we have to now discard. Innovations at school level. I will end my session by saying that these are the key challenges for the higher education systems. Balancing between teaching and research in universities and college. Definitely the balance has to shift more towards research, and more research ability has to be brought into the learners. innovations in way of linking research with teaching, delivering 21st century skills suited to individual student strengths, giving them more flexibility. Collaboration between higher education institutions and industry. Dissemination of achievement, not just by writing complex in journals, which the ordinary people won't read. And then protection of intellectual property rights and honoring of rights of others also. A culture of honoring of rights, not only my rights, honor others' rights also. We will have questions and discussions now. Yes.
Is there any questions? Participants, you can ask directly. I don't see any questions in the chat box.
Sir, can we taken the slides which you have shown during the presentation, the X and Y graph?
Bhasi sir,
Yes.
can you hear us?
Yes, sir. So we have seen that there are 4 quadrants. So in which radical innovation I have to clear that I couldn't get?
If there are no questions, I'll sum up the whole presentation, the points I wanted to make. First point is, let us start with teaching. Yes, someone wants to ask about radical innovation. Radical innovation is about finding a solution to a market, to be provided to a market which did not exist today, using a technology which does not exist. See, radical and disruptive. Radical and disruptive. Radical, architectural, radical and disruptive are in terms of whether it was a solution to an existing market demand. In radical innovation, it is to a non-existing. I gave you the example of space travel, space tourism. It was a non-existing market. No one had thought about space tourism. Some science fiction people might have. But the market was also not existing. The technology was also not existing. So that is a radical innovation. But then when you do storage cell and you make an automatic car, self-driving car, then you are doing existing market and you are doing a disruption. You are doing a disruptive innovation, because then the drivers will vanish and more of Uberization will take place. Uberization meaning resources brought to a common pool, made available to a pool of users who share these resources and pay for as they use. That is Uberization. So more of Uberization would take place. So slowly that will happen in the kitchen also. Uberization of kitchen. Could you get it when I'm saying Uberization of kitchen? Don't like to cook. And most of the unitary families, neither the husband nor the wife is very inclined to cook. So what will happen? Okay, you will order from restaurants, but the restaurant food, it is very tasty, but as far as how healthy, there is a question. So there will be Uberized community kitchen from which you will get home cooked like food. And this food will not be as expensive as hotel food. and this community kitchen, and the delivery boys will function, and every day you won't have to have your kitchen fires burning and doing the work there. But most likely, if you want to eat on your own plates, then you have to do the plate washing, dishwashing you might have to.
Okay, sir. Thank you, sir.
So there are innovations which can happen in many different spheres. For example, you find a new market. All innovations are not patentable. Innovations are new, but all innovations are not patentable. So if you find a new market or a new use to an old technology was existing, but a new use, it's an innovation. So there could be process, there could be market related, there could be delivery related. This delivery boys and the delivery systems is a delivery innovation. You don't have to go to the seller. Delivery will take place locally. Last mile, we call it. The last mile connectivity is managed by the delivery systems. So many type of innovations are possible. And one has to work at, and it solves a problem. Why did it work? Because there was a lot of need. People wanted to sit at home and yet get something from someplace quickly. So that need was there in the society, and when it came, it got a hit. It became a hit. It did not get a hit, it became a hit. So first I was saying, the point I wanted to emphasize was, in teaching our graduate students also, undergraduate students also, build in them some researchability so that they become lifelong learners. Objective is not making them researchers, but making them problem solvers and lifelong learners. Second, research at PhD level and at the higher education level, please reorient it a little more. Tilt it completely here, I won't say, from where it is tilted to very theoretical, tilt it a little more towards applied, patentable. And when you are tilting it to the applied, patentability search, patent search of the work done in that area becomes an important additional requirement in addition to the literature review that is done regularly. Connect with industry, connect with people who will use this technology to understand what, if delivered, will be interesting and useful to them. Connect with the industry, connect with the users. This is the essence of what I said. I wish all the participants all the best.